Hello student, welcome to online tutorial session. Today we will learn the representation of a sign number using the complement method. So what is a sign number representation? Suppose I want to indicate that is 9 plus 9 base 10, or this one is minus 1 1 and 1 0 base 2. So this kind of a representation is also there, minus 14 base 10. So how we will represent it in a binary format, so we will learn today. Okay, so to represent this sign part, that is a positive part for negative part, there is a distinct number. Okay, so the MSB, that is the most significant bit in the MSB position, it is MSB bit. Okay, remember MSB bit. So MSB bit represent the sign bit concept. Okay, sign bit concept. So if you represent the positive number, so for positive sign we will put in the MSB bit 0. So if you want to represent a negative number, then we have to put 1 in the MSB bit. I hope it is clear that in case of to represent a positive number in the MSB bit, we will put 0 value. In the MSB bit portion, we will put 0 value. If you want to represent the negative number, so in the MSB bit, that is the most significant bit, we will put the 1 value over here. Now coming back to the representation point of view. Okay, so now, so here the question is that you have to represent, that is positive 23 base 10 into 8 bit sign magnitude number. Okay, don't worry about 8 bit 16 bit concept. Let's gather the information how we will represent, then I will tell you what the 8 bit and 16 bit representation means. So 23 base 10 is there. Okay, right? So 23 base 10 I have to represent in binary, so that's why I need to go for the division by 2. So if you go for the division, then remainder portion is 11, remainder is 1, again 2, quotient is 5, remainder is 1, again 2, 2 2s are 4, okay, and again remainder is 1. If you go 2 1s are 2, remainder is 0, 2 0, remainder is 1. So the representation, that is the number 23 in binary, it is represented as this 10111. Okay, very good. But there is a sign bit representation is also there. So how many bit representation is there? That is the 8 bit representations. Okay, up to that I am writing over here, that is 1011, sorry, 111, not in 11 base 2. It is a 23 only. So how to represent 8 bit positive sign number? Okay, how many bits are there? 8 bits are there. So let's divide it into 8 bits. Okay, so 8 bit is there, and that first bit, that is this bit is known as the MSB bit. Okay, so if you want to represent a positive number, so positive number representation is start with 0 value. So here you will put 0 value. Okay, and whatever the answer we are getting, that is 10111, you start filling from the right hand side. 1 1 1 111, then 0 1 111 0 1, and this 2 digit is blank. If we cannot left a blank in representation, so we will put 0 value. So this is the representation of 8 bit positive 23 base 10 representation in binary. So first we have to find out the binary value of the decimal number. Next we have to, if it's a 8 bit, then 8 bit we have to showcase, and the first bit, that is the MSB bit part, we will put, if it's a positive, then positive 0, if it is a negative, then the negative value, and the bits from the right hand side we will start selecting the bits. Now let's start with another one, that is a negative one. Okay, so the number is minus 34 is there, and we have to base 10 we have to represent in 16-bit format. Okay, so what is my first job to do? First job is to we have to convert 34 into binary digits. So let's start. If you start with 12, so it will be 17 and 0 is the remainder. If you start 18, 16, 1 is the remainder. If you start 4, 0 is the remainder. If you start 2, 0 is the remainder. 2, 1, 0. 2, 0, 1. So answer is 1, 0, 0, 0, 1, 0. This is the representation. Okay, this is the representation. This is the only, not the representation, this is the 34. It is represented in binary in this format. Now 16-bit representation. How we will do the 16-bit representation? That we have to go for a 16-bit number. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 bits are there. So what will happen that if it is a negative number, so it is the MSB bit. In the MSB bit part, already I will fill 1. Why? Because it is a negative representation. Now we will start from the filling the next digit. So what is the answer? Answer is 1000. So let's start from the top digit. That is 1. The answer is 10010. So 0, last 0. I'm changing the color of the ink. That will be easier. So last one is 0, and then it is 1. Then it is 3 times 0. Okay, I'm writing 4 times 0. Okay, 3 times 0. Okay, then it is 1. And rest of the position we will put by 0, 0 value. And it is the most significant bit, here we will put 1. So in this way we can represent minus 34 or base 10 value into 16-bit representation. Okay. So now same thing, if you do, there is a complement concept. Now coming back to the concept of a complement one. Okay. So concept of complement one means how to represent. There is a two type of complement is there. Okay. That is a one complement representation and there is a two complement representation. What is one's complement? Okay. So there is a both the side complementation. So so what you have to do if it is a first one's complement. So in one's complement representation we replace 0 by 1 and 1 by 0. In one's complement we replace 0 by 1 and 1 by 0. Okay. So if a number is suppose 1000101 and you have to find out the complement of this number, what is the ones complement. So what will be the answer? It is very easy. Whatever ones is there, you put 0. Instead of 0, you will put 1. 1, 0. 0 in place of 0, you will put 1. In place of 1, you will put 0. This is the ones complement representation of this number. Okay, this is the ones complement. Okay, now we are moving back to the twos complement concept. How to find out the twos complement value? Okay. Twos complement. To find out the twos complement value, what you have to do, we have to find the ones complement value first. Okay, so first express the number in the ones complement format. After that, we will add 1 with it. Okay, add 1 with the ones complement to get the ones complement. So how to get? First ones complement of the number, then plus 1 if you do, then we will find the twos complement of the number. Okay. So now let's take an example how to do it. Let's find out 100110. This is the number, so you have to find out the 2's complement. So 0 will be replaced by 1, 1 will be replaced by 0, again 0 will be replaced by 1, and 1 will be replaced by 0. Very good. This is the 1's complement of the number. And now we will add 1 with it. That is 1 plus 1 0, 0 plus 1 plus 1 0, carry over 1. That carry 1 plus this 0, 1, 0, 1, 1, 0. So this is the 2's complement of the number. So in this way, we will find out the 2's complement. So if the question will come, some number of minus 14 is given, you have to find out the 8-bit 2's complement representation. So how to represent a negative number, you know, and whatever value you are getting, just do the opposite. But the thing is that the sign bit representation that is there, that will be also change. First, if you represent a positive number, then we have to change it in the negative number, and then so on. Okay, so first, in case of sign bit 2's complement, 1's complement representation, always find out the positive number first. Okay, positive sign representation, then you have to convert it into the if it is a negative, then negative. If it is a positive number, so it will remain same, and then 1's complement and 2's complement, so on. Okay, I hope is clear to you. Thank you, student. I'm ending my lecture over here.